Hello. Have you ever wondered how companies maximize their profits or minimize their costs? In this video we will show you how this happens, the process that must be carried out for its realization and the importance of doing it correctly. Linear programming is the part of operations research that studies the optimization of a linear function subject to a set of restrictions. Also, linear operations research is a discipline that arose during World War II in England in the face of the need to determine the best use of war material. But it is until the Second Industrial Revolution that it begins to be part of the branch of administration. The origin of linear programming is not entirely clear as of the context of the Cold War made it difficult to spread out the work from the Soviet Union. Despite these circumstances, the pioneers in this field are the Soviet mathematician Leonid Kantorovich and the American George B. Dantzig. In 1939, Kantorovich raised and solved a problem with linear programming structure, but his work was shared only in 1959. Dantzig is perhaps best known for being the creator of the most famous procedure for solving linear programming problems, the simplex method published in 1949.
Building a linear programming model. Linear programming works with a problem, which must be well defined to make it easier to define data. Data that is presented implicitly or explicitly, as well as data extensions that have the two characters already mentioned. And the objective that was set must be well specified for easy understanding.
Components of the mathematical model of linear programming. All the models, including linear programming, consist of three basic components. Number 1. Variables. Within the problem or situation arise is what is being analyzed. In addition to being the first step in the development of a mathematical model, hence the importance that they are well defined. Number 2. Target function. These are the results you are looking to obtain. For linear programming models, these results can be to maximize or minimize the target function. Number 3. Restrictions. These are the limitations raised in the problem or situation. This can be explicit, that is, that they are mentioned, or implicit, that they are inflated from the objective being searched.
Main phases of linear programming. Number 1. Defining the problem. Involves determining the three main elements of linear programming: alternatives of variables, objectives, and restrictions. Number 2. Construction of the model. It's the transformation from what was already proposed while defining the problem to a mathematical model. The most used method is the linear one. Number 3. Model solution. According to Samuel Aylon, one of the English leaders in operation research, is optimizing is the sense of the absolute, satisfying is the art of the feasible. So the solution of the model must be as attached to the sense of the absolute as long as there is coherence with the time taken in the study and the cost of it. That is the solution that maximizes the objective set out. Number 4. Validation of the model. It's the verification of the effectiveness of the mathematical model. That is, that the results obtained are consistent with the objective or goal proposed at the beginning. Number 5. Implementation of the solution. This last stage, as the name says, is the implementation of the results obtained. During this stage, close monitoring should be given in order to identify in time any deviations in the results proposed by the model, in order to make corrections to the model.